Hello, everybody. Welcome to a new episode of AZ Security. Today, we have a new topic about enhancing cybersecurity workloads with the newest technology, MCP KQL Server. My name is Dinan Paardenkoper. I'm a cloud architect at IT Impressive, and today I have a special guest, and his name is Arjun. Arjun, could you introduce yourself, please?
Yeah, hi Dinan. Yeah, my name is Arjun Trivedi. I'm working with Microsoft from last 6 or 7 years, and I joined Microsoft from the threat hunters and working as a senior security researcher with working on non-Microsoft product to develop the securities and automations and do the research on recent threats on the non-Microsoft products and improving the security uh, for the cyber attacks. That's pretty much. Uh, uh, about myself, I have a total 12 years of experience uh, into the security industries, mostly into the domain like malware analysis, threat intelligence, and automations development and threat hunting. Currently, mostly focused on the security development for the third party integrations and the non Microsoft products via Sentinel tools and trying to automate the flows for the SOC analyst via some automations and AI workflows.
Okay, and which third-party tooling are you working on currently, if I may
So
ask?
currently, am I focused on the Okta, AWS, uh, CloudTrail logs, AWS Guard Duties, Google Clouds. So those are the very core topics I'm currently working on to build do the analysis on the non-Microsoft products, on third-party products, and find in the telemetries, analyze the telemetries, creating detections on the malicious activities based on the attackers' mindsets and real-time attacks we are finding from those kind of environments and creating the detections for Microsoft Defender suits where
Wow.
we can generate the security uh, from Microsoft Defender to non-Microsoft products.
That's a big challenge, if I may say so, definitely. And for today, we're looking to the new technology, MCP. For the people that are not familiar yet with MCP, can you explain what it is, in short?
Yeah, sure. Let me share my screen. MCP KQL Server, which is the AI powered tools, which is provide functionality to AI LLM models to execute custom queries within AI prompts, and then you can uh, use those contexts that LLM can analyze the data and provide you a much easier and rich response based on your questions. So currently, the main problem statement I could say like SOC analyst because every day like 50% of their times they are spending on the creating a custom queries to find the results from the telemetries and building a KQL queries to uh, or improve the KQL queries to create a detection. So this is the main problem statement, and I am trying to solve this problem by KQL MCP server, which will help to analyze the data, creating new KQLs from the natural language, and also help to analyze the investigations and incidents to investigate and analyze the entire malicious activities end to end.
Okay.
Um, yeah, so that is the high level overview about MCP KQL server. Currently, this MCP server has two tools where schema memory tool which contains the CAG technologies like cache argument generations, which is used to creating natural language to Kusto queries from the AI prompts. and one is the executing Kusto queries, like parsing a Kusto queries from the AI prompts and execute the KQL query over there and provide the response to LLM, and then LLM will provide a detailed report and analysis based on the user prompt. Yeah. So just giving you the detailed overview about MCP KQL server. So in the KQL, whenever you give the prompt to the AI clients, so that times it will process the KQL queries to parsing from the prompt. It will extract the KQL queries, then it will analyze the and analyze your data, analyze the KQL queries. It will also try to pull out the schema memories, like schema of the tables, and also try to understand what is the query about. It will create a context about the queries and also analyze the data which is generated from the KQL. So that is the like how it's working. First of all, it will parse the KQL query, then it will execute, it will analyze the data and do the investigations based on the user prompt, and then it will also create a schema memory into the background in your systems only. So it will not uh, supply any data from your system to another server, but it will generate one KQL schema memory file within your systems. To that file will help to generate more context about your tables and to store queries, and then it will help to create a natural language to SQL query creation. So that is how it's working. This is very high level overviews, but I would like to also introduce how the like what are the modules in the detail is working. So in the first of all, when we give the prompts, that times we have to give the one sample query like take 10, take 100 something. So
Mhm.
in that case, what happened, it will create a parser of the parsing a KQL queries from the prompt, and it will extract the KQL query from your prompts like natural language and Kusto queries, and then
Mhm.
Kusto queries will be get executed, and if LLM also will test like if this queries needs to be optimized or not. Like if sometimes we have to make efficient Kusto queries to reduce the CPU usage, and so for that it will also check the Kusto query formations, and then it will try to optimize the Kusto queries, and then it will execute the Kusto query, which is the new optimized query, and then it will also utilize the context from the schema memory. So that schema memory is the main key features of these MCP tools, where uh, it will generate more context around your Kusto query, around your schema memory, like schema of the table, and the results what is generating from the Kusto queries. So that is the main module which is help to LLM to provide the proper context in proper format, and that LLM can able to create a actual Kusto queries from the natural language, and
Nice.
that is the provide more accurate result from the LLM to which is the queries mostly like 80 to 90% accurately getting executed. And also the last part is the result generations, which is the provide a more detailed results from the Kusto query executions, like whatever response is generating from that. The LLMs try to create a very UI based result, where it will include the myriad graphs and charts. So whenever if any analyst or any person is using that tool, so reading the output, they will
Mhm.
see the charts and some graphs, so it will understandable very easily to the details, very easily people can understand.
Okay. Can I also give the formatting to the KQL command? Like I want to have the result in specific, I don't know, PDF or other formats.
Yeah, yeah. So it has a features like you can just give the some wordings like I need a bar chart or I need a timeline window where I can analyze the attackers, the timelines. So those kind of things we can just provide as a one liner over there. So in the backend, what happen? It will use the pyramid formations. So it will whenever a results comes, it will try to fit in that formations and it will generate the best UI, whatever data is generated.
Nice.
Yeah. So I'm just giving the more detailed architecture about like how the MCP server is developed. So this is the MCP server. If you see, like this is very high level overview about how the MCPs works. So whenever we ask the questions, LLMs will process those questions. Okay, and through that process, it will try to understand. Okay, which are the tools I have where I can utilize to uh, follow the user instructions. So it will
Mhm.
go to the MCP servers, and then MCP servers will call out the tools. So MCP servers contains the multiple tools, could be a 5, 10. Currently in our MCP server contains only two tools like Custo executions and schema memory. Okay, so similarly, this is the high level diagram, and in the schema memory, it has features like natural language. It will process to LLM. LLM will create call out a KEG a module like cache argument generations, and then
Mhm.
it will validate the Custo authentications within your systems and execute the Custo queries within the AI prompts, and then it will format the results like provide a UI. So here I can just give you the very basic overview like client in the sense where your AI LLM is working, like could be a cloud AI or maybe custom applications or VS Code or Chat GPT, whatever. Like the prompt where you are just giving. So that called the MCP client. The MCP server where three modules is the main like MCP server, KQL authentications and memory generations, and
Mhm.
then it will core components like a query processor where the new queries gets created and also handle the errors and also check the schema memories. So those are the three main modules, and then it will execute the custo queries, and then output it will again give the data from the multiple clusters like cluster 1 2 3 from the edx, and then it will generate the response to llm, and llm will provide the response to user within the same client environment. I'll give you the very high level like how it's working. Currently, I'm using a VS Code where I have enabled the Copilot, like GitHub Copilot, which contains the multiple models. You can see like uh, here we have multiple models. Currently, I'm using Cloud Sonnet 4.5, and here I'm just giving a high level prompt like AI, you need to work as a SOC analyst. I'm give and use the MCP KQL server, which is the tools I have already installed. How to set up a tool that I'll just give you the little bit slide. It's very easy. No much configurations needed. You just need to add the MCP KQL server once you install in your systems, and then you can execute the Python because it's based on the Python, and you can just give the argument like MCP KQL server, so it will directly get started in your systems. And you can also check the output and see the, okay how it looks like here. So here you can see the MCP SMQ servers and which is versions is got loaded here. So those kind of informations you can see here.
Okay.
So this is how you can set up in your systems, and currently I'm just running the servers and giving the prompt like you are act as a SOC analyst and use the MCP KQL server. I'm giving you the authentication events log for your executions. You need to visualize high level metrics about the logs, how many successful and fail logins was happened. Give me informations about geographic distributions, user activities, and give me a graph format with anomalous behavior detections, and give me a suspicious logging patterns. So this is how you can just give the high level prompts what you want. I have also given the Custo queries like sample Custo queries. Here you can see only limit 100 and giving you authentication events. And I'm just running on the test database. So I'm just running this data. Now you can see what happens. Now LLM is checking the uh, prompt, and now it will extract the KQL queries from the prompt. So you can see like this query I have given, that is query is getting executed, the 100 one, limit 100, and it will learn the data, how it looks like. So this is the response generated by running the KQL queries. And you can see like this is very fast, like within 1 second of time window the query got executed. Now what happened, it will just checking, okay, now let me execute the KQL query to analyze authentication event. So what happened, like it will again create a new KQL query by learning of this previous response. And it will analyze the another, it will create a new KQL query. It has
Mhm.
executed it. Success is true, it means it's get executed. And it has also created multiple response, like how many events was there, what is the result over there. So this kind of uh, queries got executed. So based on the our prompt, it will get the context from there. It will learn the context from the previous response and also learn the context from the schema memory. So these three source of details and context, it will get processed and create a new SQL queries and get executed.
Okay, so
Here you can see like multiple queries got created, executing. Now it will also like learning a new data sets, like finding a anomaly detections by itself. It's we don't need to do anything. And after the last is now creating a report, a visualizations. So it will pulled all the data from the Custo clusters, telemetries, find the relevant data, and check the what are the informations are there, and then it will process the data based on our instructions, and now creating a report into our system. So in HTML format. So,
okay. So basically, you're saying in summary, I have a KQL of in natural language. I want to have this rows from these tables. Give me the format. In the first one, he will say like, well, this is the KQL query, so to speak. Shall I run it for you, basically? And if you say like, let's go,
yeah.
then he will fire each rule which you have to find in your first natural language command, so to speak. And at the end, of course, the format because of you asked the system, right?
Yeah, exactly. So LLM doesn't know like which clusters we are gonna use. So first of all, we need to give the clusters informations and table information. So it will generate the schema into the background. So I'll also would love to show you like how the schema memory works. So that is the main module which is generate the schema of the clusters. So this is how the schema memory looks like. Database it will create like which database we have used, which table we have used. So those kind of informations is get created here. It will create a token, special tokens for the LLM. So this special token will help to LLM to analyze and process the data very fast and accurately. And
Hmm.
it will also provide a summary of that particular tools names or maybe table names, and also find the sample values. It will also find the data types of that particular column. Okay, and this all the data will get fed to the LLM. So LLM can process these informations very fast accurately with AI token.
Hmm.
And then it will also keep storing the successful push queries. So if LLMs creating new KQL, it will take also a reference from the previous successful Pusto queries executions, and then it will generate a new KQL queries from using this information.
Looks great.
Moving to the report which is generated. So final report what generated. from the our MCP KQL server. Yeah, so here you can see this is the two file it has created. One is HTML report, one is MD like markup files it has created. You can see the quality of the report. It's very detailed and very neat and clean. Like we given the instructions like you are act as a SOC analyst. So it's acting as a SOC analyst and creating a report based on the SOC analyst what they are creating. Here you can see like a comprehensive security investigation report which give the analysis informations table which used time period and also checking the executive summaries. Okay, what is the active attacks they could find, and also see the key metrics like how many total authentications attempt events was executed, what are the successful logins you could found, what are the file logins found, detail high level metrics about like analysis of the particular event investigations globally, like what are the regions the events was from. So very high level to a narrow level is going down, checking the high level geographical distributions and also checking the usernames. Okay, these are the users. Our total 17 attempts was happened, from 16 was failed, 17 from multiple IPs, and failure rate is 94%. Only one spot succeed. So this is very critical. So this also getting categorized by itself, LLM. And if you see the attack pattern analysis, source IP analysis, those all things doing by LLM automatically. It will also give the temporal analysis where giving the high level overview about which times it was peak activities of attack and which times it was suspicious activities or maybe uh, low frequency of the attack. Also giving the high level time windows like timelines and giving the attack distributions, security recommendations, and also it has created a few useful custom queries to find this attack graph and creating detections like credential password spread detections creation. If you wanted to create a detections on high risk user accounts related things, or maybe spike of detections on activities. So those kind of detections you can creating by this SQL query. So this is also done by LLM. Here it's also giving informations about MITRE attack mapping, like how the MITRE has creating like how we can link this attack with MITRE framework
Right.
and giving the incidence response tracking very fast. And now, so this is the markup file. It has created very generic report, and also it has created a, HTML file. Maybe we should open on browser. So this is how the report generated by LLM, which giving the very high level overviews, critical findings, graph representations, geographic distributions with particular graphs, and also giving for reactivity patterns. It will also giving the table format with HTML embedding and attack paths with suspicious and attack tagging with information. And this is also you can see the immediate actions like what kind of recommendations actions they can.
Well, it looks very promising and also giving a lot of information and yeah, directly access that you have to do something on your behalf of the organization. So I really like the overview. Also, the other view which you have shown, which gives complete information. Also, the countings I really like. It's giving you a lot of information and a lot of clearance what is good and what needs attention, basically.
Yeah. So if you like how to you can set up. So this is the MCP KQL servers we built for community edition. So this is the GitHub repo where you can find the MCP KQL server within my repo, which also contains all the informations about how the flow chart of this KQL MCP servers executions. It will also provide information how the schema memory works and also giving you instructions how you can set up in your systems with the AI prompt. So this is are the all the interactions I have added. I really love to if can people can use it and give their feedback on this.
Yeah, definitely. We're going to share the link on this video below so that everybody can take a
Yep.
look at this. All right. Are there any thoughts? Any thoughts that you want to give to the viewers?
Yeah,
Any
yeah.
of the
So, yeah, I'm really open for collaborations on this MCP server development. If anybody are using this one, if they have some feedback, they can directly reach out to me via email, LinkedIn, or giving the creating issues here or feature requests within the GitHub, and would love to collaborate more on these tools, and would love to hear your feedback.
All right. Arjun, I want to thank you very much for your presentation, also for your great demo. I think there's a lot of added value there, making KQL query creation a bit easier, so to speak. And I think this tool can really help in simplifying a lot of KQL creation.
Yep, definitely.
I really love the way that you have shown it. It really has some potentials, and I can't wait for the new versions that come and see the improvements there.
Cool.
Um, Thank you very much for your time. For the audience at home, thank you for viewing, for watching. If you have any thoughts or ideas, leave them on the comments below. And for now, I would say thank you very much. And till next time, take care.
Thank you. Have a great
Thank you.